All right, guys, we're looking at number 2 on chapter 18 and 19 test or quiz. So wildlife scientists studying a certain species of frogs know that past records indicate the adults should weigh an average of 118, a standard deviation of 14 grams. Researchers go out and take a sample of 50 adult frogs and weigh them. Sample mean is 110 grams. They want to know if this is weird or not, that their sample mean was so low. So first thing we need to do is recognize what type of data that we're dealing with. Are we dealing with numbers that where we can calculate averages and those types of things, or are we dealing with categorical data? This case in particular, we're dealing with averages or means, and along those same lines, we've got a standard deviation that's attached to that mean. So that's the first thing to recognize is we're dealing with means here. All right, and not proportions, not proportions. So what they told us was that the population mean is expected to be 118 grams. So we use mu to represent population mean. They also told us that the population standard deviation they would expect to be right around 14 grams. So that's information that we have so far. Researchers collect a random sample of 50 adult frogs and weigh them. So for our sample, we've got 50 adult frogs, so n equals 50. And of those 50 adult frogs, we've got a mean weight, or an x-bar, of 110 grams. So essentially what we've got is, we know that this should be the case for the entire population. We went out and took a sample, and we got kind of a low weight for the average weight of these frogs. We want to know if this is unusually low, or if this was just kind of due to random sampling variability. You know, I just happened to grab 50 random frogs that, were a little bit underweight. All right. So first thing we need to do when we're analyzing this is check the conditions, because before we can do any kind of calculations, we need to go ahead and check the conditions. Well, here are your 3 conditions, and I'll just copy this stuff back up here. What we've already done. Here are 3 conditions. First condition is this were these frogs randomly selected for our sample? It says right up here that it's a random sample of 50 adult frogs. So we just make note of that. 50 frogs were randomly selected to be in the sample. All right, next thing we want to address is the weight of one frog independent of or from the weight of another? I think it's okay to assume that weights are independent of one another in this particular case. If you don't buy that, then maybe you can say proceed with caution, but generally weights aren't going to be affected from one to another if we grab a random sample. Lastly, we need our sample to be less than 10%, and I think it's reasonable to assume that our random sample of 50 frogs of this particular species is likely less than 10% of the population of this particular type of frogs. All right, so we've checked our conditions. Conditions check out. What do those conditions enable us to do? Well, they enable us to use the normal model in order to basically address the question of whether this particular sample mean is weird or not, is abnormal or not. So they enable us to use the normal model, so we need to go specify that model. How we specify that model? Well, what we're going to do is we're going to use these population parameters. We know what should happen, so we need to use that. And the other thing that that's going to factor into what your model looks like is how big is your sample. All right, so our model is going to be specified by the population mean. The population mean. So the population mean in this particular case is 118. If we know that it's a population mean, well, that is going to describe any sample that we take. That's going to be the center for all of the collection of sampling, for all sampling distributions. So we're going to use that as our center, use what we know. The next thing is dependent upon how big our sample size is. So our standard deviation of our particular sample of the sampling distribution is going to be the population standard deviation over how big it is. Our population standard deviation is 14. We have a sample size of 50, so 14 over square root of 50 is going to give us the standard deviation of our sampling distribution in this particular case. All right, so we go through and we calculate, simplify a little bit, and the normal model that we're going to use is centered at 118 grams with a standard deviation of 1.98 if you plug that expression into your calculator. So here's the distribution we're going to use in order to tell whether our particular sample mean is abnormal or not. To tell whether something's abnormal or not, we want to address the issue of how far away from the mean is it. So we're going to look at our data point here, which is our X bar, and we're going to compare that to the actual mean, or the mean of our distribution, and then divide it by the standard deviation. In other words, we're going to find the z-score, find out how many standard deviations away our particular data point is, our X bar is from the population mean. All right, so we want to find the deviation of our point compared to the mean, and then divide that by the standard deviation of the sampling distribution. When we do that, we find out that our z-score is 4.04. So this is great. What we need to do now is address the question. We know that our z-score is 4.04, but what does that mean? Well, in this case, it means that our sample weight, or our sample mean weight, is of 110 grams is actually 4, and in this case actually it's negative 4.04 standard deviations away from the mean, meaning that it's over 4 standard deviations below what we would expect to happen based on this sampling distribution. So our response to this, we know that anything over 2 standard deviations away from what we would expect to happen is considered abnormal. In this case, we're way over 2. So our response to this would be that, yeah, of course, this seems unusually low. So we would say something to the effect of our sample mean is 4 or actually a little bit more generally, is more than 4 standard deviations away from the population mean. And it is therefore unusually low. Let me extend the page so you guys can see the full answer here, but that's what we're looking at. Our sample mean is more than 4 standard deviations away from this population mean, or the population mean of this particular distribution, and is therefore unusually low in this case.